What exactly is a cipher suite? Well, if you think about it, the algorithms that we use right now for cryptography, they're going to continue to evolve. And this is because the horsepower that we have to compute the output of these algorithms is going to continue to increase. And not only that, cryptanalysis is going to continue to reveal problems and security flaws in the algorithms that we're using today. A real life example of this is the data encryption standard, or DES. Now, this particular encryption algorithm was approved by NIST back in 1977, so it's not a brand new protocol by any means. Its approval was withdrawn in 2005, and just prior to that, in 2001, AES was adopted by the NIST as the standard protocol for encryption. The reason for this is because as computing evolved, as we became more advanced, it became feasible to purchase the hardware. It was reasonably priced, and that hardware could then be used to crack DES encryption. So again, this is what we need to think about in terms of our crypto algorithms. Now, a cipher suite is a group of protocols that are put together to perform a couple of different things. So we're going to talk about those in this section. We're going to turn our attention to SSL or TLS. Now, SSL is secure socket layer, TLS is transport layer security. TLS is essentially the replacement of SSL. So as SSL has evolved, it's become TLS. And this transport layer security is designed to be extensible and modular. It provides client-server encryption. It takes care of the key exchange. It also provides message authentication code algorithms, and those algorithms can be changed without having to overhaul the entire protocol. We don't have to replace SSL with a brand new SSL or replace TLS with a brand new TLS. We simply change the protocols that we're using within TLS, and our version number changes along with that. So for example, TLS 1.2 added SHA-256 and SHA-384, and those are two different hash algorithms. Now the SSL TLS Cipher Suite defines algorithms for performing key exchanges, for doing authentication. It defines encryption, as well as message authentication code algorithms. This is a PCAP of an SSL negotiation. And what you'll notice from it, this is just a small snippet of that SSL negotiation. But what's happening is 26 different cipher suites are being offered. And these cipher suites are different from one another. They have different settings and different values, different combinations of encryption algorithms, hashing algorithms, and so on. Now, the key components of a cipher suite include the message authentication code algorithm of the MAC, the encryption algorithm, the key exchange algorithm, and the authentication algorithm. So let's take a look at three examples. We're going to start out with our first example, which is part of TLS. It's one of the cipher suites. And this is the TLS ECDHE ECDSA with AES-256 GCM SHA-384. Now let's break that down and see all the elements that are contained in here. First of all, this has ECDHE and ECDSA authentication and key exchange algorithms. Well, what does that stand for? Well, we know EC is elliptical curve. The DH stands for Diffie-Hellman, and the E stands for exchange. Again, EC stands for elliptical curve, DS stands for digital signature, and the A stands for algorithm. So we have an elliptical curve Diffie-Hellman exchange and an elliptical curve digital signature algorithm that we're going to use for our key exchange as well as our authentication. So the authentication would be digital signatures, the key exchange would be Diffie-Hellman. We have encryption that is using AES-256 GCM, and because we're using this authenticated encryption mode, the GCM here, there's no reason to use a message authentication code. So for this particular cipher suite, we don't do that. We are using SHA-384 for our pseudo-random function. Now the abbreviation for that is PRF, And what a pseudorandom function is it's the definition of our king material. It's how our king material is handled. And it's what generates our king material. Now this is just one example. Let's take a look at another. This is our second example. This is TLS, ECDHE, ECDSA with AES 128, CBC, SHA-256. Okay, so for this one, again, we see that it's a Diffie-Hellman key exchange and a digital signature authentication. We see that we are using AES 256 Cipher block chaining. We've already learned about our ciphers and understand that Cipher block chaining uses a piece of one block to generate the key material for the next block. So each block is related to each other. Then we have a SHA-256 MAC. That's our message authentication code, SHA-256. And we're also using SHA-256 PRF. And for TLS 1.2, this is the default. Now, currently, we're on TLS version 3. But what you're going to see is a lot more of TLS 1.2 implemented, since TLS v3 is a draft standard. And the third example of a TLS cipher suite is TLS ECDHE ECDSA with AES 128 CBC, SHA-256, and P384. Well, once you look at a couple of these get a little bit easier to read, don't they? The ECDHE, we know that's our Diffie-Hellman key exchange. The DSA tells us that we're using digital signature authentication. We have AES 256 with Cipher block chaining as our encryption. We're doing a message authentication code of SHA-256, and we're deviating from the default for PRF. In this case, we're using SHA-384.